The next speaker I'm going to introduce, she's known as Joannah NANJEKYE. On Twitter, she's Captain_Joannah. She's a captain, a software engineer, and an open source contributor. So Joannah is a Rails Girls Summer of Code alumna, software engineer, and aeronautical engineer to be from Kampala, Uganda, that has held 2 programming positions working on fintech projects. She writes a lot of Python, Ruby, and Golang. She is a proud open source contributor. We have started in summer programs like Outreachy and Rails Girls Summer of Code, working on Qt browser, and self-writing. She is the author of Python 2 and 3 Compatibility, a book published by Appress. When not coding, she gets curious about space and galaxies, plus a bit of guitar. One thing that is in common with most of our speakers and engineers is that they are interested in artistry stuff as well as coding. Feel welcome. Take it home.
Thank you very much, Michael. So I'll be speaking about Ruby in containers. I prepared in my slide to just say, so I'm Joannah, I do open source and write a little blogs and books and a book. I have a book and working on my second book. So I said we're going to talk about Ruby in containers. We're going to find out how do we containerize a Ruby application, what are containers, and why would you actually containerize an application? So currently, if you want to deploy an application, you probably think about 3 things. You may think of deploying your application on a physical machine, or a virtual machine, or containers that I can elaborate later. So on a physical machine, what typically happens is you have a server or a computer, and you typically host one application per machine. Okay, you can host multiple applications on the machine, but some of the libraries may interfere. The libraries of the applications may interfere. But also, if you deploy, in the case that you decide to have just one application running per machine, you may not fully use the resources, your computing resources for your machine. So what happens? You want to fully use your resources. However, if you do that, some of the libraries in the different applications you may have may interfere. So you may choose to use a virtual machine, or rather you virtualize your hardware. So what happens is that with virtualization, you'll have a hypervisor, and the hypervisor will help you run other guest OSs on the same physical hardware or physical machine. And then in those guest operating systems, you can have different applications running on each guest OS. So in that case, you'll have solved one problem. Your applications will be able to run independently. No, you may not have interferences in maybe libraries of the installed applications because you have systems operation, which is very good. But now this setup also has a problem. Like booting up an instance of the virtual machine takes quite a few minutes, which is too long. Yeah, so that's why we need containers. Now, containers solve especially the bit of how containers spin faster. So what are containers? Ideally, in normal sense or in layman's language, they're just packaging for anything. It could be a packaging for fruits or anything. So imagine you wanted to carry many things in your bag. You want to carry a cake, you want to carry popcorn, and you want to carry soda or water. You won't just pour them all in the bag. You probably want to package them in something so that they are kind of separated. There you can easily deliver whatever you're carrying to the destination when everything is safe. So in layman's language, that's what we use containers for. However, in software engineering, the concept is the same. Containers are a sandbox for our application. We logically package our applications so that they can run abstracted from the environment, so that just like when you carry water in its separate container, you're able to carry it and it won't interrupt maybe the rice in another container. So you're able to carry everything up regardless of the environment in which it is. The same happens to the applications we put in containers. They're able to run independent of the environment in which they're running in. So containers may have similarities with virtual machines, but like I've said, with a virtual machine, a physical machine will usually have a host OS, and we'll have a hypervisor so that we are able to run other guest operating systems on top of the host operating system. However, with a container, we have a host operating system running on a particular machine, and then you have a container runtime, which could be anything like Docker or any other container engine that you can use. Then you run your applications on top of the container engine. So containers run faster. It's easy. It's faster to spin a container than a virtual machine. A container will probably take you a few seconds, and a virtual machine will probably take you a minute. Now, I'm not saying that containers totally replace the use for virtual machines. There are instances where virtual machines are actually your best. Yeah, for example, virtual machines will work best when you want to have system separation. Yeah, so they'll work better than, but whenever just need application separation, containers will work best. So, what are the benefits of containers? Whenever you have an application, many applications running in isolation, and they're not dependent in the environment in which they run in, we get a lot of benefits. If you've ever coded something and it works on your machine and it doesn't work on someone's machine, I think you know what that means. So you again have to fix the other person's machine to ensure the application also runs on his machine. But with containers, we have a great sense of portability, because I package my application with all the dependencies it needs. And so when I move it from my laptop and I put it maybe on another laptop, it will run seamlessly, provided it's running a Docker, a container client, or Docker, a container engine like Docker or something. It will just run seamlessly. Of course, that's just a layman's language, but in real world, applications move environments. They move from development to staging, they move from development to production. And so you want to have an ecosystem where your system reliably runs on every environment, so you have to reduce the dependencies. So with containers, we're able to achieve that portability. And whenever we work with containers, our applications move around in image format. And that's powerful. Like the whole bit of having an application in an image, security-wise, you can sign that image. Yeah, so there are a couple of benefits with having an application in image format. But also, with containers, we can easily scale to meet our needs, traffic, and everything. Containers may not, they give us the ingredients to easily scale. On their own, they may not maybe automatically scale, but they give us the ingredients and the ability and the ease for us to scale later, automatically scale later. Then we can also cluster our application if we use containers. So, how do you create a container? A containerized application? I think that would be like the next question. So, at its core, we'll have a Dockerfile. It all starts with a Dockerfile. So, I'm explaining containerization in the context of Docker. So, we'll have a Dockerfile. It's a normal file you write with a couple of instructions. Then you'll have, from the Dockerfile, we'll create an image, like I said. So look at an image like it's an instance of a container, yeah? So write your code, then you write a Dockerfile, having all the instructions to create an image from your application. And then from the image, that's where we can create many instances of a container. So just like a class and an object, a class is a blueprint from which you create objects. So think about an image like a blueprint from which we can create many instances of a container. So how does Docker really work? What happens is you install the Docker client on your machine, or on your machine because you need to use it to maybe pull and push images to somewhere, to a Docker Hub. Now, Docker Hub or registries, I'm saying Docker Hub, there are very many other registries, image registries. So think about image registries like GitHub for images. So GitHub is for our code, but like registries like Docker Hub are for images, because all our images, we store them or we keep them on a registry so that whenever we need them, we pull, and we can pull an image if we want to use it, or we can push an image so that other people can access it. Yeah. So how does a typical Dockerfile look? That's an example of a Dockerfile for a Sinatra application. So the first instruction we'll have is from where we specify the base image. In this case, we're using Ruby 2.3 as our base image. Then run, we'll use it to execute different commands that will typically have run on your terminal, yeah? Maybe upgrading some tools or installing some tools. Then we create some environment variables with env. Then we run still. In this particular Dockerfile, we are creating a directory. If you use Linux, a Linux system, you're probably familiar with the mkdir command. We're basically just creating a folder and copying all our application files in that folder. If you use Ruby, at some point you have to install bundle, do bundle install. So whatever you do on your machine, those are the instructions you specify in the Dockerfile. Then with CMD, we use the CMD to issue any commands. Like for example, in this case, we're running a Sinatra server on port 80. Yeah, so all the commands that you typically have running locally, maybe when you're moving environments, those instructions we put in a Dockerfile. So these instructions, at first, maybe it may be hard, but you can always look around details on how we can write a Dockerfile. So a Dockerfile doesn't have an extension. That's the difference. So it will usually be at the root of your application, Sinatra or Ruby or any Ruby application you have, and it doesn't have an extension. That's one of the rules, and it should be called Dockerfile, just like the title of this slide. Yeah, that's its name. So after you've created a Dockerfile, like I illustrated earlier, the next step you have to do is now build that image or create that image. So if you've installed Docker on your machine, the Docker client, the command is very simple. You just say docker build -t, then your image name. And then after you've built your image, you can run your application with Docker run on whatever server you have, on whatever port, in this case, port 80. Yeah, so that's how we containerize a simple Ruby application, a Sinatra application, write a Docker file, then build your image using the Docker client you'll have installed on your machine with Docker build, then you can run your container with Docker run. So in this case, a container is, you cannot decouple a container from the application. In this case, whenever I say Docker run or I'm running the container, I start the application instantly. So you can't decouple a container from the application that runs inside the container. So whenever you start the container, you start the application. Yeah. So when do you use containers? There are benefits of using containers, but there are also when would you use a container? Because I believe that containers shouldn't be used in every case, just like anything. Shoes are used for something. When you're going to sleep, you probably put off your shoes. So containers also have their use cases. One, if you want to adopt a microservice architecture, you probably are better off using containers because they have all the ingredients to easily help you achieve such an architecture. So in other words, if you already have a monolith and you do not need, in other words, you do not need a microservice architecture, probably rebuilding your application to just use containers is not the best thing if you have no need. Yeah, so if your application can run as a monolith, you do not use just because people are talking about Docker, just don't. It will be a lot of work without a very good case for you in this case. But also, I already said portability. Of course, we all need portability at some point. You want your applications to run reliably in every environment, in whatever environment you put it in. Everyone, all of us, we don't develop applications for our own consumption. We code the applications, then put them somewhere for other people to use. So your application will always change environment. So, but if you want to have that reliability where they will run regardless of where they are put, you're better off using containers. Yeah. Then also, if you want to run batch jobs, yeah, you're better off using containers. So when you have like a few containers, life is very simple. Like your applications run reliably. You have like 3, you can even name them Joannah, Mike, and Banter. So you probably know now if you wake up and there's probably something wrong, you'll know probably some container 1 is not working. But when you have a few thousands of containers, you can't keep track of all of them. So you need a way of automating, or you need some other management system to help you keep track of all those containers. They may be running on different nodes. By nodes, I mean they may be running on different machines. And so you need a way of keeping track when you have very many of these containers. So that's what Kubernetes is for. Kubernetes, I'll use the word they use on their website. It's a container orchestrator. I think if I didn't use it, you probably go Google and say, she actually didn't use the exact word. So it's a container orchestrator. But what that actually means is that it simplifies the way we manage containers. So what typically happens is that Kubernetes helps us to manage our deployments, monitor our applications that are in this case running in containers, and to automatically scale. I told you that by default, Docker containers just give us the ingredients to automatically do some of these things. We can easily monitor, because they're isolated, we can easily monitor, and we can easily scale to meet our needs. However, Docker just gives us the ingredients. So how do we, with deployments, we're using Kubernetes, we are able to specify a deployment by specifying the image from which to create the container and any resources that the particular container may need, RAM and any other resources, storage, CPU, and all other things. However, with Kubernetes, we also monitor our applications that are running in containers. We monitor their health. We monitor, and we are able to auto-recover every node or a particular application in case it's not running. You're able to auto-recover, like auto-start it. So practically, what this means to a developer is that if you are on a honeymoon, they probably want to call you back to office to heal something. Yeah, I think that's great. Yeah, so because you'll have auto-healing nodes, I think that's power with Kubernetes that comes with Kubernetes. I know some of you don't want holidays, but there are others who actually enjoy holidays. It's like an excuse for you to leave your honeymoon, but you no longer have an excuse for that now. Kubernetes helps us do that. So, but also, I already said scaling. It will automatically scale your applications to meet to meet traffic. All you need to do is have enough nodes, enough machines, enough servers or enough computers, and then it will automatically spread the applications on the different nodes depending on the traffic coming in. So if without Kubernetes, think about what would happen if you needed to meet traffic. So you'd first have 2 computers, then you say, okay, the third one, I don't need it. So when the traffic comes, what happens is that there are some requests that you'll fail to meet, then you'll notice, I think I need more servers, then you'll go fix a server and then configure stuff afresh. But with Kubernetes, provided you have your nodes, you just specify and it will automatically scale depending on the incoming traffic to meet all your needs. Yeah, so Kubernetes looks like a bit of a complex thing, but it's actually simple. So I'll go through just some of the terminologies with Kubernetes. In Kubernetes, we have something called a pod. And a pod it's just a group of containers, which is like a deployable unit of containers, a group of containers that can be thought of as a single application. So they share the environment and resources, and yes, so they share and they can communicate through localhost. Yeah. Then we have a node. Whenever I say node, just think about it as a physical machine. somewhere. It could be a server or a computer. Then you have a volume. A volume is basically like storage. Yeah, then we have a concept they will call a service. A service is groups related containers into a single entity, and we provide access to them, a single access to all those containers to the external world. So the external world thinks it's actually, I'm accessing one application, but you know at the back we're having like 16 separate applications, but to the external world, they're actually seeing one single point of access. So the basic architecture of Kubernetes has 3 components. We have a client, a master, and the nodes. So a client could be anything. It could be an API or a command line interface or a GUI. And we have something called kubectl, okay, kube control. It's the most commonest used. Then we have a master. The master is in charge of routing all requests from the client, and then the nodes, the ones that handle all the workloads, or they handle all the work in the cluster. So all these 3 components put together, the master and the nodes, they form something we call the Kubernetes cluster. And then, of course, we have the registries. That's where our container images live. I told you it's like Docker, it's like GitHub, but now for images. So typically, a client will make API calls to the master, API calls which could be requests to do something in the cluster. But it has to go through master, because master has something called a server, an API server, which services the requests that come in from the client. So then the master, like the name suggests, is the king in the cluster. It's the one that gets requests from the client and services them. However, it also does majorly 3 things. Of course, it has the API server, which the client queries all the time. And then it does scheduling. It schedules the nodes to handle all the work, to handle the workload given to it. Either it schedules all the nodes that to handle every workload from the requests coming either from the client, yeah. But it also does control. It controls the health of the nodes and spins up another instance of an application when one is not working, yeah. But also we have something called the etcd. Think about it like it's a single point of truth in the Kubernetes setup or cluster. So it will typically have configuration information, and it basically carries the state of the cluster. So whenever a node or anything in the cluster wants to know any information, or we want to know the state of anything in the cluster, etcd it's a single point of truth. Yeah, then, like I said, the nodes are they do the donkey work here. They handle all the workloads, all the work that needs to be done in the cluster. So it has something called, it has a layer called the supervisor D layer. And if you're familiar with supervisor D layer, is that when we run processes under the supervisor D layer, we're able to ensure that all these processes run at the same time, all the time. Yeah. So we'll usually have an operating system running a Docker client. and the kubelet, which is an agent, in case the health of the current update was compromised. Kubernetes also gives us a concept of the API. Everything in Kubernetes interactions take place through an API. So this comes with an advantage in a way that APIs are easy to integrate with or work with in that case. So it's easy to work with Kubernetes, in short. So with Kubernetes, we also have through daemon sets, you're able to do logging and general monitoring, of the cluster and all your nodes and all your applications running in the different containers. So I already said, like I said, containers logically package your application, abstracting them from your environment, and Kubernetes helps us manage all those many containers that are not easy to track manually by yourself. So if you want to know more information about how you can containerize your applications and how you can use Kubernetes, I have a lot of content I've written online. But plus I'm also writing a book on the subject, so you can check it out to know more details on how to work with containers, Docker, and Kubernetes. Thank you.